Assalamualaikum and good day to Dr. Saramli and those who are watching this video. Today our team will be presenting about separating immiscible liquid of different densities, and our team consists of Nafitra Haikal Bisukapli, which is me myself, Nushafika Natasha binti Nolizam, and Nu Aina Najwa binti Muhammad. Just a brief introduction regarding this topic. What is immiscibility? Immiscibility is an ability of the two substances to mix and form a homogeneous mixture where the dense component will sink while the less dense fluid rises to the top. However, density is a kind of physical property which can be determined when the mass of an object is divided by its volume. However, regardless of the shape and size, density will always rely on the materials itself. Immiscible liquid separation is widely used in the application of water treatment, petroleum refinery, food manufacturing, and medical field. However, there are some drawbacks, which is difficult to efficiently separate two immiscible liquids due to its different densities, and existence of impurities such as particles or other liquids can interrupt the separation process. The separation of immiscible liquid can be done in two ways, namely lab scale and industrial scale. As for the lab scale, the commonly used equipment is laboratory centrifuge, hydrocyclones, and decantation using a separating funnel. However, in industrial scale, the commonly used equipment is conventional gravity separator, hydrocyclones oil water separator, and this stack centrifuge. As for centrifugal separation, it is a process that utilizes centrifugal force for separating immiscible liquids in a mixture. The mixture's denser component moves further from the axis while its lighter component moves closer towards the axis. As for the working principle, it operates based on their density under the influence of gravitational force, and there are two types of operational modes, namely sedimentation principle and filtration principle. There are two types of centrifuge used in the lab, which are tubular ball centrifuge and disc centrifuge. As for the tubular ball centrifuge, it has the capability of handling low solid concentration and has a small capacity. And the direct access to the ball is possible with the underdriven batch machine, whereas the ball is suspended from above for the overdriven batch centrifuge. As for the disc centrifuge, it comprises of conical discs that divide the liquid flow into several thin layers, and it processes feed at speeds of up to 30,000 gallons per hour. Moving on to decantation. Decantation is a process that separates components of an immiscible liquid. As for the working principle, the heavier liquid, which is the more denser liquid, will sink, whereas the less dense or the lighter liquid will float. In the simplest form, decantation utilizes gravity to separate immiscible liquids, where the lighter component is poured or siphoned off the top of the mixture. As all of you can see, this is the figure of gravity decanters with its labeling, and this is the working principle of this equipment. First, the heavier solids will quickly adhere to the imperforate or solid ball wall under the influence of the different densities of the phases, while the lighter phases rises to the top. In solid ball decanters, the liquid flows around a helical scroll before being discharged over wave plates. A horizontal gravity decanter is more preferable compared to vertical design due to its maximized ratio of phase border between the two settled layers. However, the vertical decanters are better suited, such as in low flow rate applications and space restrictions. However, it depends on the situation itself. Sometimes people might get confused between filtration and decantation because they might look the same. However, in fact, they are different in terms of its operational. This is the difference between filtration and decantation. The filtration itself is a process of directly separating a whole solution through a filter, with the filter trapping the solid and allowing the liquid to pass through. So, it is not suitable to separate two immiscible liquids because the liquid still can pass through the filtrate. However, in decantation, it is the process of removing a liquid from solid contaminants that have accumulated at the bottom of the container. So, the pouring out the less dense liquid allows the separation of two liquids with different densities. Just now, we've been learning about centrifugation and decantation, but what is the difference between both of them? First, centrifugation, it uses centrifugal force to separate mixture, whereas for decantation, it utilizes gravity to separate mixture. For centrifugation, the centrifuge will spin at incredibly high speeds, where it will force heavier components to sink to the bottom and lighter components to rise to the top. Compared to decantation, the mixture is allowed to remain undisturbed for a period of time, which it allows the heavier component to sink to the bottom. Finally, as for centrifugation, it is expensive but very efficient to separate immiscible liquid. Compared to decantation, it is more cost-effective, which is cheaper compared to centrifugation, but it is less efficient compared to centrifugation. Moving on to the industrial method, there are two types of separator that commonly used in the industrial, which is conventional gravity separator, API, hydrocyclone oil separator, and the stacked centrifuge. Moving on to the conventional gravity separator, which is commonly used in the petroleum industry, or to be exact, in the petroleum refinery. So, as the working principle and application, this equipment is used to separate most of the oil, such as emulsified oil, fuel oil, and dissolved oil from the effluent from a refinery. The discrete oil globules will rise to the surface of the water due to the buoyant force, which it will form an oil layer, and it operates based on Stokes' law, where separate oil and water droplets based on their terminal velocities. A water droplet's terminal velocity is lower, hence, as a result, it takes longer time reaching the bottom. And how can we increase the separation efficiency? First, the greater the difference in densities, the more efficient the separation will be. Second, when the larger the oil droplets, the faster they will separate from the water. And finally, the taller the separator, the more time the oil and water have to separate. Moving on to the second application in industry, which is hydrocyclone oil separator. As for the working principle and application, this separator is a type of enhanced gravity separators which use aqueous solutions as the main feed fluid via centrifugal force. It is commonly applied in the offshore oil industry and wastewater treatment for recovering oil from streams. And here are some main sectors with this function, and I have attached together with its figures and the labeling. First, the separator has a tangential inlet and a conical chamber. The feed mixture is introduced into the separator tangentially, which creates a vortex or eddies. The heavier water droplets migrate to the interior of the vortex, whereas the lighter oil droplets move to the outside due to the centrifugal force produced by the vortex. Oil droplets then leave the separator through the bottom outlet, whereas the water droplets will exist or will be leave through the top outlet.
Next, this stacked centrifuge can be used for industrial scale. It is widely used for oil purification at the final stage of extraction process. It is a type of centrifuge separator where it is very versatile techniques which can be used for separating solid or liquid mixture in continuous, semi-continuous, and batch configurations. The disk spacing is determined by the viscosity and solid content of the feed, which must be adjusted accordingly. How it works? Firstly, this centrifuge separates solid and one or two liquid phases in a single continuous process. The centrifuge uses extremely high centrifugal forces to separate the phases. So, when such forces are applied, the denser solids are pushed outwards against the rotating wall, while the less dense liquid phases form concentric inner layers. So, the interface position is the location where these two different liquid phases meet. This is easily adjustable to ensure that the separation is as efficient as possible. The stack increases the surface settling area, which significantly speed up the separation process.
Assalamualaikum and hi, my name is Nur Syafiqah Natasha binti Nolizam. I will present about comparison application in laboratory and industry scale for separating immiscible liquid. So for laboratory scale, there are 4 applications that I discussed, which is division of whole blood component, distillation of water and ethanol mixture, cleaning murky water, hexane and water separation. For industry scale, pollutant removal in stormwater treatment system or refineries, extract essential and also analyze drug product. And now let's proceed to application of separating immiscible liquid in laboratory scale. Firstly, centrifugation. Centrifuge are employed to separate liquid, gases or liquid according to their densities. For the application, there are two applications that use centrifuge, which is purified of cell, organelles, virus, protein and also nucleic acid. And also for the application is division of whole blood component. The full blood sample is allowed to clot at room temperature in order to get serum. The clot is subsequently removed from the sample by centrifugation. For the next application is using fractional distillation, which is fractional distillation is the process of distilling a substance to obtain a substituent parts or fraction. For the application of fractional distillation is to distill a water and ethanol mixture, purify reagent and product, and refine oil. Water boiled at 100 degrees Celsius, whereas ethanol boiled at 78.4 degrees Celsius. The most volatile component, which is ethanol, will therefore concentrate more in the vapor emerging from the liquid as the result of a heating of the mixture. Let's move to the next application that use decantation. Decantation is a term that used to describe the process of the removing solid contaminant from the liquid solution. However, in order to separate two immiscible liquid of the different density or remove insoluble solid particle from a liquid, decantation also can use. So for the application of decantation is cleaning murky water. As you know, the process to separate immiscible component by transferring the top of the layer to separate container, which is clean water is drained because the soil and the other particle will sink to the bottom. Lastly, application in laboratory scale is using separating funnel, which is two immiscible liquids such as oil and water can be separated using the separating funnel. The principle of this separating funnel is two immiscible liquid are placed in the separating funnel and given some time to stand, which is the lighter liquid from upper layer and the denser liquid at the lower layer in the separating funnel based on the different densities. So this application can capable for filtration, purification, solvent extraction, concentration, demixing, separating liquid and distillation. And also this application also can use in hexene and water separation. Okay, now let's move to the application of separating immiscible liquid in industry scale. So firstly, we talk about gravity separation. Levitation and hydraulic washing are the term of gravity separation, in which a water stream is used to separate the lighter gangue particle from the heavier ore particle. For the application is pollutant removal in the stormwater treatment system. As you know, removal occurs to downward of the solid denser than the water, like sediments, and upward a solid lighter than a water, such as dispersed droplet of a petroleum, oil and pepper. For the next application, we using fractional distillation. Fractional distillation in which utilize in petrochemical and chemical plant, natural gas processing facilities, and organic air separation facilities. This application of fractional distillation oil refineries. Fractional distillation in industry is used in oil refineries to separate crude oil into a useful substance. In terms of the lowest boiling point will depart from the column at the top, while the product with the greatest boiling point will exit at the column at the bottom. Next, we have liquid extraction. In this method, chemicals are separated by two immiscible liquid solution, typically one aqueous and one organic. This liquid extraction has many applications in industry. Firstly, in agriculture sector, to find disease-resistant genes in crop, increasing agriculture production and lowering crop loss risk, and also minimize future livestock and food harvest. Second application in pharmaceutical sector, to isolate and identify protein, antibiotic, amino acid, and enzyme. Lastly, in manufacture sector, which is to extract essential oil to make fragrance, flavors, and medication. Lastly, from me is chromatography. Liquid chromatography is the effective separation technique that has been successfully used for the separating and analyzing wide range of sample. Sample type is water soluble, oil soluble, compound, ionic, and non-ionic compound, as well as biopolymer like nucleic acid and protein. This application of chromatography is there are 3 applications in chromatography, which is in pharmaceutical industry, to analyze drug product, to separate their various ingredients, to check drug trace inside the patient. Also in food analysis, for testing undesired ingredient in food products. In petrochemical industry, used for plastic, solvent, fertilizer, plant products, and insulting material. That's all from me. Thank you.
Next, we move to the conclusion. So to conclude, immiscibility is the property of two substances that prevents them from combining to form a homogeneous mixture. So the components of an immiscible mixture will separate, where the less dense component will rise to the top while the more dense component will sink. So this we can see, for example, oil and water are examples of immiscible liquid, as they are not soluble in each other. We can see that oil will float on the water because it is less dense than water. Liquid extraction is one of the examples of this mixing. It is a process that involves successive mixing and settling stage. The two liquids are combined with a solvent that selectively dissolves one of the mixture's component. So, centrifugation, separating funnel, decantation, and filtration are the example techniques for use in a lab scale. Meanwhile, hydrocyclone water oil separator, conventional gravity separator, these type centrifuge are used for industrial scale. That's all from us. Thank you.